Okay, we are on 8.1b. Maybe, if it'll ever pull up. Okay, so we talked last time about when something is a function and when it's not. So if I had a bunch of people and a bunch of towns, as long as no person lives in two towns, then that relationship is a function. So in this case, we have four people. So people A, B, C, and D, and they live in towns 1, 2, and 3. And the way I've drawn it, no person lives in two towns, so this is a function. But if person 2 or person C suddenly spends half their time in one town and half their time in another, that can exist, but it is not a function. It doesn't fit the definition of a function. So, can we look at a graph and determine if something is a function or not? Well, let's look at graph number 1. So this point is negative 4 comma 2. Well, let's do it this way. Negative 4 comma 2. And then this point is negative 2, negative 3. This point is 0, negative 5, 2, 0, and 3, negative 5. Does any person live in two cities? No. Okay. What if I put another point right here? And that would be 5 comma 0. So I put person 5, and they also live in city 0. Is that a function? Yes, it is. So what if person 0 now lived in these two cities? So I'm going to go over here and write 0, 3, negative 3. Now suddenly it's not a function. Is it possible to look at the graph and figure out if it's a function or not without writing down all the numbers? What is it about this point that makes it a non-function? On the same vertical axis. So what Tice said is, if I can draw a line and hit 2 points, that's not a function. And that is called the vertical line test. If you want to know if something is a function, we just draw a vertical line and we ask, does that vertical line ever hit any 2 points? And in this case, we're good. So yes, that's a function. What about this one? No. And the phrase we use is, it fails the vertical line test, so it is not a function, because that person, what is it? That person is person 3. Apparently, person 3 lives in 3 different cities, which is fine, but that is not a function. Okay, what about graph 3? It fails all over the place, right? Okay, what about graph 4? Fails, so not a function. Graph 5? Fails. Right? Do I ever hit 2 different points? Yeah, all over the place. What about graph 6? That one passes. I never hit the graph twice. What if I had this? What if I had a closed circle that came over with an open circle, and a closed circle which came over to an open circle? Would that be a function? Well, the only place we really need to worry is right here. Do I hit the graph twice? No, because the top one is an open circle, so the top one's not really there. But the bottom one is a closed circle. Do you see that? What if I filled this in? Now it fails the vertical line test and it's not a function. Okay, here it just wants the domain and the range. The domain is just going to be all of the x's. So -2, oh, we need the funny brackets. -2, 0, 2, and 4. So I needed the x's. And what is the range? Well, it would be 4, 2, and -4. So 4, 2, and -4. Is this a function? Does it pass the vertical line test? Yes, it passes the vertical line test, so it is a function. Okay. So here I want to know what is the domain. So which people are in this function? Which x's? Well, is person number 5, -5, part of this function? Well, if I look straight up or straight down, can I find a point on the graph? No. So -5 is not. What about -4? Are they in? No, they're not. What about -3? Yes. -3 can be found right there. What about -2? What about -2.5? Yeah, in fact, all of the people going across are in this function. What about person 5? Are they in? So if we look down, we have an open circle, which means it's not there. So no. So could I just say -3, -2, -1, keep going, 2, 3, and then skip 4? Would that be good enough? Does that leave anybody out? What about person 1/2? They're a little shorter than the rest, but they're still a person. So we need to figure out a way to include not only the integers, but every number in between. So what you used to do was inequalities. So this is my domain. So we used to say -3 is less than or equal to x, which is smaller than 5. And you can still do that. That is called inequality notation, and it's something you probably learned in elementary school, and it still works. But once you get higher in math, we really don't use that anymore. Instead, we use, for an equal to, we use a bracket, and for a not equal to, we use a parenthesis. And then we say the low number, comma, high number. So in this case, what is the lowest x that's part of the graph? So it would be bracket -3. The reason it's a bracket, that is a closed circle. -3, comma, 5. And 5 is not actually there. So we use a parenthesis. Okay. What about the range? Is city 5 part of this function? So I look to the left and to the right. Is there any person in city 5? No, there's not. Okay. But city 4 has a person in it, and all of these cities have people in them until I get really close to -2, and -2 is not actually there. So remember, bracket means equal to, parenthesis means not equal. What is the lowest city that we have? What's the smallest city in the range? Well, it's everything from here to here. Do you see that? So the x-axis are the people, the domain, and the y-axis are the cities. So the smallest city is -2. Does that get a bracket or a parenthesis? Because it's not equal to, so we put a parenthesis on it. Okay? Technically, it's called a parenthesis, but that's just obnoxious, so I don't say it. Okay, and the highest one is going to be 4, bracket or parenthesis. Bracket. Okay, do you need to see another one of those? We can do one more. Well, we can do as many as you want. Okay. What people are part of this function? Everybody from person -5 all the way up to person 3. So my domain is going to be what? Bracket -5, good. Three with a parenthesis. Does everybody understand that? All right, now we look at the towns. Every town from -3 up to 4. So my range would be, what's the low number? -3, bracket or parenthesis. It's equal to, so bracket, all the way up to 4. Okay, does that make sense? All right. So we know what it means to be a function. Every person lives in a single city. It's okay if a city has more than one person in it. But there is a special type of function that's useful in particular ways that we'll talk about later. And that function is called a one-to-one function, which means it's a function. Every person lives in one city, but every city only has one person in it. That's called a one-to-one function. And if a function is one-to-one, it allows us to do some stuff that we can't do with non-one-to-one functions. So we can test if something is a function by using the vertical line test. So that vertical line test tells us if one person lives in more than one city. But if we want to test if a function is one-to-one, then we draw a horizontal line. And that tells us if any city has more than one person in it. So you're going to do the horizontal line test in this assignment, but it's not really going to mean anything for a while until we get to some later topics. But the horizontal line test lets us know, is the function one-to-one? So graph 1. If I move that horizontal line around, do I ever hit the graph twice? No. There is one spot that gives us a little bit of a worry right there, but one is an open circle and one is a closed circle, so it's fine. So this passes the horizontal line test, which means, yes, it is one-to-one. What about graph 2? No, it fails all over the place. What about graph 3? Yes, that one is one-to-one. Graph 4? Yep, passes. Graph 5? Passes. Graph 6? No. There are 3 people living in that city. It is a function. It's just not a one-to-one function. Okay. So here we have an equation delivering sugar. So how much does it cost to deliver sugar? Well, the cost to deliver sugar is, so the cost is $130 per ton plus a delivery fee of $3,500. Okay. So what is my domain and what is my range? Well, domain would be the inputs. So the tons of sugar, or the amount of sugar, I guess. So the amount of sugar is the domain. And if we click here, the company can transport up to 30 tons of sugar. So what would the domain be? Well, it's going to be the set of all numbers from 0 to 30. And the range is how much it costs to transport that sugar. And what is the outcome going to be? Well, we're going to need to do a little bit of calculation. How much is it going to cost? Well, is it 150 or 130? 130. So let's say I deliver 0 tons. 130 times 0 plus 3,500. So just to have the truck show up is $3,500. Well, the maximum amount that I can deliver is 30 tons. So a full delivery would be $7,400. All right. So here we have a parabola, and we want to know what is the domain. So remember, domain is the x-axis, the people that live in cities. So does person 0 live in a city? Yeah, if I go down, I get this right here. So person 0 is connected to city -6. Okay. What about person -7? Do they live in a city? It doesn't look like it, but see how this has an arrow? So that's going to go down forever. So person 7, -7, does live in a city. I don't know what it is. It's way down there. Okay. What about person 10? Yes. Can you find a person that does not live in a city? No. They all have a city somewhere. Some of them are going to be really, really, really small numbers, negative numbers. But every person lives in a city. So if that's the case, we can either say the domain is everything from -infinity to infinity. That means all numbers. And notice I put parentheses on both of those. And the reason I did that is, can we equal -infinity? No. So you never put a bracket on infinity. You just can't get there. Okay. So that's the domain. You could also just click the button that says all real numbers. I think there's one of those. Let's check. Yeah, all real numbers. Okay, what about the range? Does anybody live in city 8? So we look to the left and we look to the right. Nobody lives in city 8. City 8 exists, but nobody lives there. Okay, so as I come down, what's the first city that has people in it? 2. Now, is 2 an open circle or a closed circle? Well, it doesn't say. If it doesn't say, it's always a closed circle. The only way it's an open circle is if the open circle is actually drawn. Okay? And then, how far down do I need to go before I quit running into cities that exist? -infinity. Okay? So when I do the range, and I do low, comma, high, what is the lowest city number? 2 would be the highest city number, right? -infinity. So my range is -infinity. Should I put a parenthesis or a bracket on that? Parenthesis, because we can never equal infinity. All right? And then what is the high number? 2. And that gets a bracket. Oh, but look, they don't want us to do interval notation. So how do we turn that into an inequality? Well, we put y in the middle, and the left side is not equal to, and the right side is equal to. So it would be -infinity, oh, to 2. And actually, I don't need this. So the answer is just y is less than or equal to 2. All right, this one does not belong. Okay, get to work.